Hello! Solar cells produce electricity, reliable and without the need for any operating supplies, simply with the power of the sun. We are fascinated by this technology, together with many millions of people who already draw electricity from the sun with big and small solar plants. We from GP Solar and Solmic provide our supporting services, so solar modules can be produced at a low price in huge integrated factories, and solar energy can at last become a more important part of power production. I invite you to discover the making of solar modules together with me.
An integrated solar factory with a production site for the metallurgical silicon, the big polysilicon plant, the crystallization furnace for ingot production, the wafer production, the solar cell production site, and the module factory. There is also a central administration building, as well as optionally a solar cell academy and an own solar power plant.
In the beginning there is sand, silica sand to be exact, since it contains mainly silicon dioxide from which we extract the precious silicon. By the way, silicon is the second most common element in the Earth's crust, so we won't run out of it. Together with coal or other source of carbon, the silicon sand is melted down at over 2000 degrees Celsius. The result is metallurgical grade silicon with a purity of almost 99%. When it cools down, metallurgical grade silicon solidifies into a shiny crystal such as these.
Metallurgical grade silicon can be made of nearly any kind of sand. Still, it makes sense to use very pure materials. Herewith, a purity of already 99% may be reached. To produce it, the silica sand is put in a furnace together with a source of carbon. This alloy is melted down at 2000 degrees using an electric arc. In this process, the oxygen and silicon bonds are broken and carbon dioxide and the silicon that we want to extract are formed.
No great difference at first sight. Metallurgical silicon and polysilicon. But this one still contains 1% of impurities, while solar power production needs a purity level of at least 99.999999%. Such a high purity can only be produced by liquefying the silicon, cleaning it by distillation, and finally depositing it onto a silicon seed sample.
The metallurgical silicon will be cleaned to a very high purity in the polysilicon factory. Since it is very difficult to clean it in its solid state, the chemical process is done. The chunks are milled and liquefied, and then this fluid is cleaned in a distillation process. This happens in the high towers that can be seen here. Afterwards, it is directed into the so-called Siemens reactors. And this is how the purified gas is transformed into highly pure silicon. The gas is fed into the reactor where it deposits on the bars. In order to process the silicon in the next step, it is broken into pieces again and then carried to the ingot factory.
Pure silicon, the basis for our solar power production, is created. But how can we make the electrons flow in the silicon? What makes our little water pump work just with the power of the sun?
A silicon solar cell. It can create electricity because of this trick. During the manufacturing of ingots, boron is added to the silicon. And later, during the processing of a cell, phosphorus is diffused into the silicon. As a result, two different layers are created. The region between the layers creates a kind of wall for the electrons. They cannot get past this barrier by themselves, but by the help of photons they can overcome it. Now, more and more electrons gather at the upper side of the solar cell, where they push each other aside, but they cannot cross back because of the barrier. By connecting the upper and lower side of the cell with a conducting wire, the electrons can return through this wire.
To this point, we have produced highly pure silicon. This is also used in the microelectronic industry. In order to produce solar cells, impurities must be added systematically. At first, boron is added. Afterwards, an ingot of silicon is manufactured, either as a block of solidified multicrystalline silicon or as a single crystal of monocrystalline silicon pulled from molten silicon. Both are possible ways, but in the following we will have a closer look onto multicrystalline silicon only.
For the first time, we are in a clean room. The chunks of polysilicon are filled in a crucible, and then a vial of boron is added. Altogether, it is brought into the crystallization oven, where it is melted. By regulating the cooling, it is possible to remove unwanted substances. Once the silicon has solidified, the crucible is removed and the ingot is carried to the nearby wafer factory.
Just gently pressing and the cooked egg is split into many slices. The next production step, the wafering, works in a similar way. The first cutting creates bricks with the correct edge lengths. These are then cut into very thin slices, each less than 0.2 millimeters thick. These wafers are then used for producing the solar cells.
The wafering is done in two steps. At first, the ingot. This large block coming from the ingot factory is cut into bricks. Then these are pushed through a wire saw. In it, a several hundred kilometers long wire, carrying the so-called slurry, is put through the brick. It contains finest parts of silicon carbide, which cut the wafers out of the brick. They are then cleaned in a bath and afterwards carried to the nearby cell production.
We have now passed through the first factories and our silica sand has turned into these wafers. In a factory like this, the crucial part of the barrier in the solar cell is formed and thereby the positive-negative junction in the cell is created. During this process, cleanliness is of utmost importance, since even low levels of impurities cause a bad efficiency of the cell. For this reason, the production facility is treated like a clean room and the operators must all wear special overalls. To get such a solar cell, in the end, the wafer must run through the following steps.
Here the wafers arrive. Several measuring devices guarantee a high quality of the end product. Then the surface of the wafer is roughed by running them through a chemical fluid. Now, in an oven at 900 degrees, the important step occurs, which converts the semiconductors into a solar cell. Phosphorus is diffused into one side of the cell. In order to be able to pick up the electrons later on, a grid of fine silver stripes is printed on the cell. Now, several cameras examine the cells to check the result and to measure the cell efficiency. Finally, the cells are sorted by certain criteria and then carried to the module factory.
By now, each cell can already produce electricity. In order to obtain greater power output and to offer a long lifespan, many cells are packed together in modules. Now they can provide power for 25 plus years simply once they are exposed to sunlight. By the way, in about 2 years, they have produced the energy that is needed for the entire production, including setting up. They can be mounted on facades, on rooftops, or even in great open-air plants. How these modules are produced can now be seen in the animation of our 6th and last factory.
In the beginning of the module factory, there are packages of solar cells, each containing cells with similar electrical characteristics. They are first placed in a row and then soldered together. Then these rows are placed next to each other and connected. In order to ensure that the module can produce electricity during its entire lifespan of more than 20 years, a sheet of glass is used for protection. An extra foil repels water. Then the modules are bonded in an oven. A flash simulating the sun under standard conditions tests the modules before they are packed and shipped to the customer.
About 3 watt can be produced by one solar cell, more than 200 by a module. An ordinary rooftop is big enough for approximately 5 kilowatt, so an average house will produce more electricity than the residents can use. Solar power is also getting cheaper, and plants with several megawatt have been built in open spaces, functioning as entire power plants. They herald the change to renewable energies and already represent a significant part of our energy supply. The modules are produced in highly specialized and increasingly integrated factories. GP Solar in Solmik would be delighted to help you in planning and implementing an integrated state-of-the-art factory.